It's time for another amazing chemistry video with Mr. Stapleton! Proudly sponsored by Farmer Junior Nice Coffee.
Hi guys, welcome to the next video. Today's video is going to be all about the greenhouse effect. So what I want to do is start off by actually just showing you a little bit of a diagram of a greenhouse and just showing you, I guess, why it's called the greenhouse effect. So if you're not familiar with a greenhouse, it's basically an enclosure with a whole lot of glass around the outside. Now, it works on the principle that you get sunlight coming down through the glass, and what happens is it hits the plants, the objects, everything inside of the greenhouse. Okay, so you want to get as much light in as possible. However, once it gets absorbed by the plants or by the ground or anything like that, what happens is that the light, as it's coming in, so if we actually show it, I guess, coming through this way, like here, the light comes in, hits the ground here, okay, and then it just starts bouncing back up again, okay, or from the plants here, it bounces back up towards the roof as well. Now, what's really important is that glass has what's called a refractive index, and so what happens is that the light, as it comes in, all right, is what we call short wavelength, okay, and when it gets bounced up or it gets absorbed by the plants and gets re-radiated, it actually comes out as long wavelength. Now that's really important because what happens is that that light, or that heat I should say now, can no longer escape the greenhouse. So what happens is it gets reflected back inwards, alright? So it gets reflected back in towards the middle of the greenhouse, and what that does is that actually increases the mean temperature inside the greenhouse. And that's really, really important because that, along with the increased moisture, all right, that you put into the greenhouse, allows plants to be in a much warmer, more, I guess, tropical environment, and allows for much faster photosynthesis and better growth. So that's I guess the process or the concept behind a greenhouse. So why do we call what's occurring in the Earth the greenhouse effect? Well, what I've done here is I've just whipped up a couple of diagrams here. And what I've got is I've got the sun and I've got the earth here. All right? And I want to explain to you what we mean by the greenhouse effect. So around the earth, we have a protective layer of gases. So I'm just going to, I guess, put this a little extra circle around the earth here. Okay? And we've got some gases in here. And the main ones we're looking at are carbon dioxide, water vapor, and we've also got some methane as well, and there's also occasionally some oxides of nitrogen in there. But they form a little bit like this protective blanket, so it's like the glass around the outside of a greenhouse. And what happens over here at the sun is that we've got short wavelength radiation, which is ultraviolet radiation that comes from the sun. So that ultraviolet radiation is short wavelength, like this. So it passes through this layer and hits the surface of the Earth. Okay, so that's short wavelength. All right, that's the physics symbol for wavelength. All right, if you're not familiar with it, so it's short wavelength that comes from the sun. That's the ultraviolet radiation. Okay, what happens is it hits the surface of the Earth and it gets absorbed by plants, by animals, by buildings, by the ground. So hot days, the ground gets hot because it's absorbing the heat from the sun. What happens is that then gets re-radiated, all right? So if you ever, been lying near the ground on a really hot day, you can feel the heat coming off of it, or metal surfaces, you can feel the heat coming off of it, and that is actually infrared heat. So if you put your hand on your arm, you'll feel heat coming off of that as well. That's infrared heat, so it's re-radiated heat, okay? So that re-radiated heat, okay, I'm going to use that one, sorry, because it's not working very well. So I'll show it in green. This re-radiated heat here comes out as long wavelength. Okay, so that's infrared, and the short wavelength is ultraviolet. Okay, now that's really, really important because molecules like carbon dioxide, water vapor, methane, they don't absorb short wavelength radiation. Now, it's actually the bonds inside the molecules. So if we look at a carbon dioxide molecule, like that, okay, what happens is that short wavelength radiation passes through, the carbon dioxide molecules aren't affected by it. But when you've got long wavelength radiation, such as we get re-radiated from the Earth, these bonds actually absorb the heat, and it causes the molecules to move around and actually traps some of the heat. And that's really important. So, if we now focus on the Earth here, so I'm just going to rub this out, okay, and we're just going to focus on this layer around the Earth. So I'm actually going to draw it a little bit bigger. So we'll leave our Earth here, okay, and we'll draw our protective layer around it as a little bit bigger this time. Now remember, this protective layer is made up of carbon dioxide, water vapor, and methane. All right, some of it. So that short wavelength radiation from the sun comes in like this, okay, hits the surface of the Earth, okay, and is re-radiated as long wavelength radiation. Now what's important is that some of this passes out into the atmosphere, okay, but some of it is absorbed by these gases and is reflected back in, okay. So we've got absorption, all right, by things on the Earth, and re-radiation, all right, of some of the long wavelength, and then reflection of it back into the Earth. Okay. Now, remember, it's important to realise that not all of the long wavelength radiation is trapped in the atmosphere, but some of it is trapped by this and reflected back in. Now, that's really, really important, because that does exactly the same process as our normal greenhouse. That traps heat inside the Earth here, inside this protective blanket, if you want. And what that does is that allows the Earth mean temperature, okay, to be around about 17 degrees Celsius, okay? So I should just say the temperature there, around about 17 degrees Celsius, which is really, really important, because that allows life to survive here on Earth. If we didn't have the greenhouse effect here, we would probably drop by a significant amount, and the average mean temperature would be about minus 17 degrees Celsius, which would be far too cold to sustain any sort of life like we have it. And so it's very important that we have the greenhouse effect. So it's a natural thing, it's a good thing, we want to have the greenhouse effect. Okay? The problem is that in recent years, what we've done is we have increased, in particular, the carbon dioxide concentrations and the methane concentrations. Okay? Carbon dioxide is the one that really gets focused on a fair bit, okay? And that comes from burning of fossil fuels, from combustion engines, deforestation, all of those sorts of things. So we're increasing the amount of CO2 in the atmosphere. So what that means is that we are actually getting less of this long wavelength radiation emitted back into the atmosphere, and more of it trapped by the greenhouse gases and reflected back into the into this protective blanket around the Earth. What that means is that's increasing the mean global temperature. Okay, so what we call the enhanced greenhouse effect is when the concentration of greenhouse gases in the atmosphere increases and the amount of re-radiated heat absorbed, so up here, the re-radiated heat absorbed, okay, is greater than the amount that's released into space. All right, the warming of the atmosphere occurs, which could lead to an increase in the mean global temperature. Okay, so I'll say that one more time. When the re-radiated heat heading back up here from the Earth, when the amount that is reflected back is greater than what escapes into space, okay, that increases our mean global temperature. Now, it may only be by a degree or two, but that's actually really, really significant. Okay, it can lead to a number of different problems. All right, some of these problems involve climate change. So if you think even just a 1 or 2 degree mean temperature increase would mean that Adelaide would start to have the climate of Brisbane. Okay, now some of you might think that's a good thing. You're like, yeah, I'll hit the beach all the time. Okay, but however, what you've got to think about is the impact that's going to have on lifestyles in Australia, because Queensland is going to become more like the countries near the equator, so they're going to experience much greater monsoons, tidal waves possibly. It's going to destroy their ecosystem up there in terms of the flora and fauna their production of like cane sugar, bananas, all those sorts of more tropical things. South Australian production of wine, a lot of wheat, everything like that will be changed as well, and so it's going to have a big global impact. All right. What it also does is it increases weed growth. Because just like a greenhouse where you've got warmer, moister conditions, okay, weeds grow much faster than normal plants. Very shallow roots, they rely upon fast photosynthesis, which is why they grow very fast in spring, okay, because there's a lot of moisture in there, you've got some warm temperatures, they grow faster. What's going to happen is they're going to overtake normal plants that you would plant. So if you're trying to plant crops, you get weeds growing instead, and that's going to have an effect. Okay, it's also going to increase the sea levels, because what we've got is we've got a lot of ice that's trapped at the moment as glaciers in the North and South Pole, and what's happened is, obviously, remember, ice is less dense than water, and so as those ice caps melt, what's going to happen is it's actually going to increase the water level, because the amount of water displaced by the icebergs is less than the volume of water that they have, and that's going to flood low-level islands. It's also going to actually release a lot more fresh water in, which reduces the ability of the oceans to absorb CO2. Remember, in the carbon cycle, oceans can absorb CO2, so it's going to be a double whammy effect. Okay, so how do we reduce the greenhouse effect? Okay. Well, first of all, we need to reduce our CO2 emissions, okay? But one of the other things I haven't actually touched on yet is the methane. And this is probably a really big one that people aren't aware of, that we need to really look at as well. Methane is a far less common gas in the atmosphere. However, it has 10,000 times the ability of trapping heat that one carbon dioxide molecule does. So increasing the amount of methane in the atmosphere is quite bad as well. Now, that methane comes from a number of different places, but the two main ones are rice paddies. Okay, so rice paddies are really increasing the amount of methane in the atmosphere, and also farming, and in particular cows. Okay, cows produce a lot of methane gas as well. And so we really need to limit the amount of these gases that we're putting into the atmosphere. We need to do smart things like find alternative energy sources that are renewable, don't rely on fossil fuels, so turbine wind energy, tidal energy, solar energy, all of those sorts of things which don't release CO2 into the atmosphere will be very, very helpful. If we can find ways, they're actually looking at ways to harvest the methane which is produced by rice paddies or by cows to use as a fuel as well. And that's one way of reducing its impact of going into the atmosphere. So, in short, greenhouse effect, natural, good, keeps the earth warm at 17 degrees Celsius. All right? Enhanced greenhouse effect, bad. It's when more re-radiated heat is reflected back into the earth than is allowed into space, which results in an increase in the mean global temperature, which can lead to some really bad side effects. So hopefully this has explained it reasonably simply for you. If you've got any questions, just ask. Thanks, guys.